Hello everyone, uh, my name is Timothy Mulewa Joseph. In today's video, I'm going to teach you the dynamics equations for constant acceleration, or if you want to call it uniform acceleration. They all mean the same thing. Both constant and uniform acceleration are all the same. So you are going to learn how to derive these equations for constant acceleration, and you can use them to calculate any problem involving constant acceleration in physics. So I appeal to you to watch this video to the end so that you can gain maximum understanding. Let's begin with the letters or symbols that you are going to be seeing in these equations. The letters include U, which stands for initial velocity, that is the beginning velocity of an object, the initial velocity. If you're a physics student, you will understand that every object has its initial velocity, that is object in motion. Yeah, sometimes. Then we have final velocity, which is represented by letter V, and our time is given as t. Acceleration is given as a, and then we have displacements, which is s, displacements. So you are going to see all these letters in these equations now I'm going to talk about. So pay keen attention and enjoy. Let's look at the first equation of linear motion. Motion in a straight line. How do we derive this equation? The equation for a uniform acceleration is given as a equal to final velocity minus initial velocity divided by time, which means change in velocity divided by time. So if you have this equation, rearranging this equation gives velocity equal to u final velocity, initial velocity plus at. When you rearrange, that is, you are making v subject of the equation here, or of the formula, which means you are going to isolate letter v because you need the letter v to become the subject. So we isolate it, and to do that, it's just simply to cross multiply, which is very simple. You cross multiply, okay. Do I need to explain this? Because I think it is clear and simple to do. But let me just explain. So this is assumed to be over 1, and then when we cross multiply, we are going to have at equal to v minus u, and then we need to isolate this guy to make it subject of the equation. So to do that, our at will be equal to v plus u equal to v, and then rearranging it, we arrive at this. So when we rearrange the equation, our v is definitely equal to u plus 80, and then this is our first equation. So this is very simple to derive. Let's move to the next one and see how it is derived. The second equation. Okay, let me clear the screen so that I can see it clearly. So second equation of linear motion. Let's remember that the distance moved by an object is s, which is given as average speed multiplied by the time taken. Yes, average speed multiplied by the time taken, that is distance moved by an object. So this is the expression for distance moved by an object. Because the acceleration is uniform, the average speed will be divided by 2. So change in velocity, the average speed, u plus v over 2, then multiply by this time. So which means that this is average speed, which means change in velocity, the average speed rather, not change in velocity. So the average speed, which is given as u plus v, average speed of an object, when an object is making equal distances in equal time interval. So we say it is in uniform speed or yes, and then we can take the average speed of that object using this. So here what we do is that we substitute this, that is initial velocity plus the final velocity, and divided by 2. So that is the average speed, and then we multiply by the time taken, which is this. So that is where we have our second equation as s, which is distance, bracket u plus v, then multiply by the time taken divided by 2 because it is average speed. So this is also very simple to derive. Let's move to the next one, which is the third equation of linear motion. This equation is also very important. By combining equations 1 and 2 to eliminate v, that is final velocity, we derived the third equation. So what we do here is we combine equations 1 and 2 to eliminate letter v, which is our final velocity, and then we derive the third equation. So let's see how it is done. Substitute u plus at in place of v in equation 2, and then this gives, when we do that substitution, don't forget our equation 2. Okay, let me write equation 2 for you to see it. Let me put it somewhere here. So our equation 2 is giving us s equal to u plus v, let me bracket everything, multiply by the time taken divided by 2. So this is our equation 2. So we say that by combining equation 2 and equation 1, and then equation 1 is this. This is equation 1. V equal to u plus at. So when we combine these two equations together, we are going to have our third equation. So let's see how it is done. To do that, we substitute u plus at in place of v. So this is equation 2, and then we have our u plus v here. So in that case, we substitute the v, we eliminate v and put this guy here, u plus at here, which is our equation 2. Since equation 1, since v equal to u plus at, so we replace it by this. So we combine, and then we have our t outside here, which is here in brackets, you can see, then divided by 2, we have combined. So by the time we substitute this equation, open the brackets, we are going to have u plus at multiplied by another t divided by 2, and then further simplification gives this, that is what do we have here? So we say u plus u is 2u, and then plus at, and when we say t times 2u, we have 2ut plus t times at, we have at squared. So you can see it here. So we need to bracket this. So we need to bracket this, so we need to get rid of this bracket. If you want to put the bracket, it's okay, but I think this is a minor mistake. Bracketing it, putting it in brackets is not still wrong. So it's not still wrong. Let's try to, okay, so that we will not get confused. And then divided by 2, right? So you can see we've already opened the bracket, but I think let's just get rid of this bracket. So we don't need this bracket, so I'm taking it out. And then, which means finally, therefore, our s is equal to ut. You can see when you, okay, so this cancel this. take away 2, and then we have ut plus half, okay, at square, half at square. So this is how this equation or third equation is derived. So we've got our third equation. So let's go to the fourth equation. Okay, the fourth equation, which is the last one. In this fourth equation, the fourth equation, is obtained by combining equations 1 and 2 again to eliminate t. This can be done by multiplying the equation for acceleration and equation 2, this together to give as. So do I need to show this? Okay. So again, you cross multiply. So we multiply equation 1 as by equation 2, and then when we do that, we have okay, let me just write it somewhere here so that you can have a better understanding of what I'm explaining. I need you to understand how this equation is derived. So I'm going to put it somewhere here. So we have this equation equal to v minus u velocity over time, okay, multiplied by our equation 2, which is s equal to, what do we have for u plus v, all of them in bracket, okay, and then divided by t, no, multiplied by t, and then so something like this. This is what we have, right? So we multiply the two, so we have a times s, we have as, and then we have v minus u over t times u plus v in brackets. Then we have our t here multiplied by t divided by 2. When we simplify, it becomes this. Okay, so we have v minus u, and then again you keep cross multiply, which simplify as this v plus u will simplify. Do I need to give thorough explanation on this, because this is also very simple to derive? So as is given, and then divided by 2, then let's see what we have here. So here we eliminate time. We have eliminated the time, and that is why we have this here, because time has taken care of itself. So this cancel this. Okay, I was looking for what happens to time. So since we are eliminating it, so t cancel t, and then we have this remaining. So let's multiply them. We have v times v is v square, v times u, we have this uv v. Well, okay, let me just put it outside there for some of you that may be having questions. But if you're a good mathematics student, I think you understand how this is done. The square of these guys. So v times v, you have v square, and then we have v times plus u. So I think this is going to be uv plus uv. Okay, and then we have minus u times v, so you should have minus uv, and then minus u times plus u, we are going to have plus u, oh, I mean plus u square, yeah, plus u square. Okay, let's take it as this, and then divided by 2. Don't forget as is equal to this. So when you further rearrange these guys, you rearrange, you have v square. So let's see what happens. uv minus uv, these guys go. So we are going to have something like this. So equal to v square, okay, plus u square left, right, divided by 2. So which means as, of course, here we have as equal to v square minus u square divided by 2, and then when we cross multiply, we have 2as, where we have v, and then we have v square equal to v square minus u square. So when you rearrange again, you are going to arrive at this v square equal to u square plus 2as. But let me finish this. So if you bring this equation here, let's say I bring it down, I say as equal to v square plus u square divided by 2. So it is still the same thing. So when you cross multiply and then you rearrange, you are going to arrive at this, making v the subject of the equation, v square. So you are going to arrive at this equation. So we have v square equal to u square plus 2as, and then some people have decided to write it as this. You want to put everything in square root in the square root, but I think this is how it is written, so this is correct. So let's not go wrong in doing this. Yeah, I'm struggling with my voice because I've got little cold, but I think I'm okay. It's not what you're thinking. So this is how we derive all these equations. So don't forget that for you to derive equation 4, you multiply equation 1 by equation 2, and then you eliminate t as it is done. For you to derive equation 2, equation 2 is derived from distance expression, which says that average speed multiplied by the time taken. So you can derive it, the equation 2. And then equation 3 is also by combining equation 1 and 2 again. We combine equation 1 and 2 to eliminate. So let's go back. No, if not finished with you, we go back. So we combine equation 1 and 2 to eliminate v. So we eliminate v, and then we derive the formula, equation. So in summary, so let me show you all the equations in summary of what you have learned. All these equations, okay. In this video, we have learned the 4 linear motion equations. Sometimes it is called Suvat's equation. Suvat's equation. So in some textbook, you are going to see it as Suvat's equation in some textbook, but still linear motion equation, or for uniform acceleration, if you want to call it constant acceleration, so we call it Suvat's equations. Suvat's equations. So they still mean the same things. Or acceleration, constant acceleration equations, something like this. So okay, let me get rid of this guy. So let me quickly give you the summary of what you have learned. In summary, we have considered how to derive all equations for uniform acceleration. And then the first one is, equation 1 is v equal to u plus at. And then equation 2 is given as bracket open u plus v close the bracket multiply by time divided by 2. And then the next equation, which is equation 3, is given as s equal to u multiplied by tut plus half at square. And then the fourth one is this. So our fourth equation, number 4, is v square equal to u square plus 2as. Please, you need to learn all this equation and try to understand how they are derived. It will really help you in solving problem involving linear motion or constant acceleration. I hope by now you should be able to derive these 4 equations and then learn how to apply them. I don't want this video to be too long. I will have shown you an example on how to apply, but I've made a video about that so you can find it on my Google Drive. There I've solved some problems involving constant acceleration where these equations are applied. So please do watch the videos, and then if you have any questions, you can send your questions to me. Thank you for taking your time to watch. Goodbye.